Yeah, so hi everyone. Amogh Desai here. I'm on the Airflow PMC, and I'm working as a senior software engineer at Astronomer.
Jarek, Potiuk, I'm the Apache Airflow PMC member and committer, also a member of the Apache Software Foundation and a member of the ASF Security Committee. And we don't have Pavan with us, but he has recorded part of his presentation, so we will play it alongside our presentation. Pavan is also the committer and member of the Apache Software Foundation. The three of us are the most active people, but Jens as well. Jens, who is hosting us on the Airflow CI, and we are going to talk. This is a little bit continuation of a talk I gave last year at the Airflow Summit, where I spoke about how our CI works and how we make our developers more efficient, developing easier, and improving developer experience in general with the CI. We want to talk about what happened during the last year, comparing to the previous presentation, what we have been working on together to improve our CI/CD, especially in the context of Airflow 3. And the main goal is to show you that this is a super important thing to work on the CI/CD to make developers make Airflow actually robust and working and developer experience good. And we want to invite those who would be interested to actually help us with fixing and improving our CI process. So first, I will tell a little bit about why CI is needed and a little bit of history of Airflow CI, what happened over the last few years when Airflow came from the beginning to where we are now. Then Amogh will tell about some things that we've done to make it work now for Airflow 3. And then also Pavan will tell his part. And I'll be talking about the future of what we are planning to improve Airflow CI. So why CI? If you look at the history of Airflow, it started a long time ago, more than 10 years ago. And initially, and I see Max here, who did most of the commits at the very beginning. And then it was incubated in Apache Software Foundation when it was donated by Max from Airbnb. And then became a top-level project. And after that, you could see that the velocity of changes increased and kept on increasing continuously. So we went through Airflow 2.0 in 2021. This was more or less where I joined a few months before. And then we developed between 2.0 and 2.10, adding new features, increasing the code base dramatically. And recently, of course, 3.0, 3.1. And as you can see, the growth is amazing. But also what you can see is that we have a big number of contributors, and not only committers and maintainers are committing, but we have a lot of people who are contributing to Airflow. This is beginning of September, but generally we have more than 20 commits a day over the period of the last month or so, or last several months, maybe. And we have here is 70, but 120, 150 people contributing to Airflow every week. So at some point of time, we've been 18th at the OSS rank, kind of in terms of the velocity and speed. So for all the early open source projects in GitHub. The thing with Airflow is with such a huge velocity and size of the project, we really need to make every contributor empowered to be able to commit their code and make sure that actually we do not break anything. It's been more than 5 years of evolution of our CI/CD. Since I joined, I did a lot of work there. Initially, we were running in Travis CI, and who knows what Travis CI is? There is a few people, but actually most of the, even like Amogh, Jens, and most of the contributors and committers in Airflow do not even remember that we moved to GitHub Actions, and that was a very good move. And we made certain assumptions when we created our CI. First of all, we're using a pre-built CI image, where most of the tests are run. Is like with 700. Airflow has more than 700 dependencies, and this means that if you try to install everything together on a local virtual environment in any kind of operating system you have, you'll probably fail. So if you want to, because some of the dependencies will not be installable for multiple reasons. And for that, we are using CA image when we install all 700 dependencies, and this is a way how you can make sure that everyone has the same set of dependencies, the same versions, and they run the tests in exactly the same environment. So we have a Breeze, which is our development tool that wraps around creating and using the image for testing, and a lot of different Breeze commands are used for release management and a number of other things. And the assumption was that we are using the same Breeze commands in the same environment with the CI and with CA image and Docker container in CI and locally, so that you should be able to reproduce whatever happens in the CI locally and repeat the problems that are happening in CI. This is very important because there is the famous works for me syndrome. Like things work when you have certain dependencies and things doesn't work when you have certain dependencies. Actually, we are right now fighting with one of a small problem that we don't have exactly yet in the CA image on the way right now. Some dependency updated in CI, some locally, and we have to figure out how to make sure it works. So that's an example of like one of the things that we are still continuously improve and try to make sure that this works for me syndrome is not happening. Initially, it was in Bash script. More than 10,000 lines. That was a lot of lines of Bash, which we finally got rid of and rewritten to Python with Outreach internship help, with 2 interns from Outreach. And one of the last changes we've done, and this is a kind of starting point for all our changes that we've implemented this year, we switched to UV as a driver of our virtual environment creation and installing Python as well. Why our CI is complex? Because we have a lot of tests and a lot of types of tests implemented. Like we have Airflow unit tests of different kinds, like DB, non-DB, layers dependency tests, and a number of others. We have provider tests because Airflow consists of not only Airflow, but like more than 90 providers. We have integration tests, which are testing Airflow with a number of open source components that we are interacting with. We have Docker image build tests. We have Docker compose tests. We have Helm unit tests. We have Kubernetes tests and Helm chart and Kubernetes tests and Docker compose together. So everything that we have in our repository and make it available for our users, we try to test and see if it still works in the CI. And finally, we have constraint generation, which is our way how we can let our user know how they can install Airflow in the way that is reproducible with all the same set of like fixed dependencies at the moment when Airflow was released. And there are more things. So if you can see here, this is like part of our CI. It's fairly complex, but the important thing is this one. So if you see, this is like our CI jobs in Airflow for the main run. So this is just a 1/20th of all the jobs we have. It's fairly complex and has a number of jobs to run. And it's kind of magic how it runs because we have a lot of different parts together: the Helm chart, Docker container, tests, constraints. All these things is a fairly complex code, and we have many moving parts and workflows that are working together somewhere in cooperation. For example, we have a workflow that creates an image and workflow and then every other job is pulling that image. So this is rather complex way, and I was the original author of that, and in for many years a single point of failure, because if something broke, I was the only one who was able to fix it. But last year we've done, and I've orchestrated the deliberate effort at the Airflow Summit to invite other people to contribute to the CI system of ours. We've made a training session after the Airflow Summit last year. And also then other people joined and started to contributing like Amogh. Jens was at the Jens, you were at the training, I think. And after this happened after the Python rewrite, it made it easier for other people to contribute. So the general idea is like right now contributing to our Breeze and CI system is like it's just a Python code that like the same as any other Python codes. If you're developing Python, if you know Python, you could contribute and fix the problems that you see yourself. You don't have to wait for anyone else to do it. And the guys here, like they've learned how to do it, and we can help you to learn that as well. And so more people were involved. We created internal Airflow CI/CD channel. Like we actually had the channel, we renamed it to be clear what it does, and more people subscribed. And any kind of failures that you can see right now that you have to take care about in our CI is notified there, and we can act when things fail. So few people who are involved: Amogh, Pavan, Jens, Bugra, Aritra, Elad, Ash, Kax, Silweli. Those are the people who are most active there. But we have also more people contributing. Now I'll hand over to Amogh to tell more about what we are doing now for Airflow 3.
Yeah, thanks, Jarek. So, yeah, first things first, we have not been developing or evolving CI just for fun, just because we can, but it was mainly for trying to prepare for Airflow 3 with a lot of changes coming in. We wanted to be in the best possible shape to help with the velocity of changes coming in. So we started proactively rather than reactively. So yeah, let's talk about a short story here. So the story is called Big Picture. So just you guys have seen this enough, I think, with the keynote and the sessions that we've been giving. You've seen this a lot, but just a few things of note here. Over time, it's not yet done, but over time, the providers will be consuming from the Task SDK instead of Airflow core. And obviously, we have a new component, which is Airflow CTL, which we already talked about in the keynote, but it's like a kubectl, but for Airflow. And similarly, obviously, now that we want to separate out Airflow server components from the Airflow's client components, there are obviously a lot of components and util code which is shared across components. So obviously, we want to move it into a shared library and then symlink it as needed. So obviously, it contains stuff like your time zone, your secrets masker, logging, etc., just to have a unified setup. Right. So we started very strong with a nice community-driven beginning for Airflow 3, where we had a lot of work to do, a lot of people helping with it, and we ran some simple exercises with the community, and we were able to achieve a big goal, which is Airflow 3, but we needed a very strong community for it. For example, we started with, I think Pavan did it. We started with a MyPy upgrade of 1.9 to 1.16.1, which the bump was easy, but the reactive ripple effect was a lot. So we had to run it through a nice community exercise, and we had to clean up the MyPy ignos and those ugly hashtags after the your code lines. We had to clean it up, so we ran it through them. Similarly, with the Task SDK, the base hook and the base operator have been moved to the Task SDK from Airflow core. So the providers definitely import all sorts of patterns. So we had to unify it. And last but not the least, this one, I think it's still not complete. It's an ongoing effort where all the different ways of filtering in your UI and API are which you had in Airflow 2, we're migrating them over to Airflow 3. So some of it is still available for grabs if you guys are interested. So this one, which you guys had seen a lot earlier. So how strong did we start, right? Let's see some stats. This is base operator migration. And all the stats I'm showing you were run. This is the entire exercise took like 3 to 4 days for each one of them. So with base operator, you can see there were 17 contributors, 100 plus providers, and it was done in like 4 days. Similarly, the base hook refactoring, 60 plus pull requests from 8 active contributors, again 3 to 4 days. And the last one, MyPy upgrade, which was 30 plus contributors, again 3 to 4 days. So that's a lot of PRs coming in, right? So what's the challenge with so many pull requests coming in? We're trying to work with a lot of PRs, and there are just a handful of maintainers. So tons of PRs, a lot of active contributors across a massive architectural change. So how do we know what's failing? So we do have scheduled runs which run our entire test suite that Jarek showed. More or less this entire test suite across combinations and around the clock. We run it with AMD at this cron and with ARM at this cron. But in order to be able to tell what's failing, you definitely have to be at this page, this familiar page where you can see if it's passing or failing. Obviously, I've filtered by success, but how do you think it's that easy for someone to just stay on this page and keep refreshing it, right? No. So what did we do? We did something all of us use on a daily basis, Slack, and we repurposed the internal CI/CD channel for it. So we have a Slack bot that runs 2 times a day at 6 a.m. and 5 p.m. UTC. It goes through the list of failures between the in the time that the last cycle did not catch, and it notifies failures only on this particular channel, internal Airflow CI/CD. So we started happily with the main branch only, and once we were in the process of releasing Airflow 3, we realized the release branches will need this as well, because same problem again. We did not have a person refreshing it, so obviously we needed to extend it. And if you go through that channel, you will see a lot of messages that look like this, which reports the failure on which architecture and a link to logs for the failure. So we keep getting this every day. So this was more of an enablement task so that we can catch failures early. But definitely, we due to this, we do have a lot of failures coming in, which I will talk about in terms of some example improvements we have done over the past 1 year. Yeah. So when we thought everything was going well, one fine day on May 8th, GitHub has had this blog out, right, where it updated the rate limits for unauthenticated requests. And obviously, we started seeing a lot of failures because of this, because we use the GitHub APIs, or not the APIs, the raw GitHub content for a lot of things in our workflows. So we started seeing a lot of failures, and that's kind of rooting from the fact that the new rules said that you can have 60 requests per hour, but with the number of runs that he just showed you, a number of combinations, we definitely were going way past it. And many of our workflows use GitHub for various things, and we started seeing random failures in our CI, more like forbidden kind of failures. So for this crisis, we had to go and revisit all the workflow scripts we have, be it in, we still have a few in Bash, most in Python, but we had to go back to them and example scripts such as the devil dips and the entry point CI, which were failing very often. And not just these, we had 20 plus scripts which were using the raw.githubusercontent.com for making requests. So we had to, the solution was to switch to GitHub API. We already used the runners, so we had the token for it. We wanted to repurpose it. And then we had to fix 20 plus scripts for in a similar manner. And we did not actively go and fix all of them. We were fixing it as needed. The next one, for the next one, I want to give you a recap of Airflow 3 architecture again. But what you want to note here is the Task SDK has a REST API client that can talk to the API server, and obviously the API server hosts the execution API. These are the two things I want you to pay attention to. Why? Because these are nice unit tests, right? But you can observe a few things here. The unit test on the left-hand side is the unit test that's present in the API server or the server side of Airflow, and on the right-hand side is in the Task SDK, which is the client side. So everything looks good here, but what's actually happening? They communicate using the contract between the two is JSON objects. So you can observe one thing here, that we have a unit test that is serializing the actual value to simulate the client SDK, right? And in the end, when we are verifying the response that the server will send, we are again deserializing it to assert it. So we're trying to simulate the actual situation. And similarly here, we have a similar thing where we serialize the expected value and then again we assert it as needed. But what's the hidden effect here? We are simulating things. So what can happen is this. During the critical time of 3.0.3 RC4, we had this particular bug where we do not have tests that cover the interface between the two. We have unit tests that are happily running on the left-hand side and the right-hand side, but nothing to bridge the gap. And hence we ran into a classic problem of this. Classic, right? So we ran a simple exercise where we actually went ahead and started testing we kept the unit tests. They are all obviously needed. And then we had to extend it to start also testing what's important, which is the interface between the two. So we came up with the Task SDK integration testing framework. And what this does is, this basically does something like this. You do not have to read it, but it spins up the entire Airflow instance, an actual Airflow instance, and tries to make calls to where it matters. It tries to spawn a SDK client within the process, tries to contact the API server and asserts the actual formats that the interface should be passing along. So don't have to read it, but that's one exercise. Just wanted to show you that we have done such things in the CI to improve quality of the CI. With that, I'll pass it on to Pavan's part, which we will play.
Hey all, thanks for joining thanks for joining the session. Hi, I'm Pavan Kumar. Sorry, I couldn't make it to Airflow Summit. So let's get into this one, making process robust. So continuing to Amogh's discussion on the testing strategy. So what we further implemented is we implemented end-to-end testing for the DAX and CI. So first of all, why we need this one is to know does all integrations between the Airflow components is working or not. So as part of all the core operators, we provide all the example docs, right? So you can see in all our Airflow site in the docs. And so to me, is like provide example docs are working. And also, as I said, these test which reveals like a testing integration between the different components, like the DAG processor, API server, scheduler, DLL. So all these Airflow components are working or not. By using these example docs, we can not to know whether these are working or not. So. And of course, if any user comes, right, as a first-time contributor or user, if they want to know about Airflow, they'll start and using these example docs. If something breaks the example docs itself, they'll have to do it, right? So they'll all need to work out. So And another reason is for these end-to-end tests. Right, this is we are about to add this one remote logging. So as you see here, right, with after Airflow 3, there are a lot of issues right, around remote logging broken, and I think these kind of things we were able to get to know once we implemented this end-to-end test with the remote logging. So the plan is to add first for the AWS using local stack. So it's already in progress. So we'll add soon that. So we at least get to know when this test breaks, the remote logging is broken. Um, yeah, that's on this end-to-end testing. So yeah, you see here, right? So this is what our test execution in our CA, where end-to-end test, you see all these example DAX, which we have provided in the docs we are executing. And you see all these examples are, right now it is working fine. If something breaks, we'll get to know the Slack channel and our team will fix it, yes, these things. So continuing on that, so another process we made it seamlessly working is right. So part of the Airflow 3 development, there are around 300 plus developers are working. So if you want to backport any changes, and so far until Airflow 3, we are doing manually all the backporting. So so as a PR author, if your changes to be ported into the past release version and want to make it that available in the patch version, what you need to do is you have to raise the change for the main branch and I'll get to backport that into the patch version branch, right? So what we did is we asked like why don't we automate this one? So thanks to TP and Amogh, the initial suggestions to use some GitHub Actions, we tried that one. Due to some restrictions, we didn't use that one. And also TP suggested there is automated cherry picker, which developed by TensorFlow Foundation. So we used that one to be automated. So that what we are doing is we add labels, and whenever PR rises, right, we add labels and it gets automated backported. Of course, yeah, if there is if there are any conflicts, it rises a message in the it raises message in the PR itself, and it letters you that know so they can manually do backport. So with this automated cherry picking, right, we enhance team productivity and we use what the 100 plus developers working, and you in a day you get like a 20, 30 plus PRs rising into main branch, and yeah, it definitely helps maintainers a lot to make these changes automatically backported into the other branches, right? So yeah, you see, right, this is one of the example you can see. So what we do is whenever, let's say you want to backport into the last release version, let's say V301, V30. So what we do is we have a burning sideboard, which is developed by Coxel for adding automatic labels. So that bot will add backport to V3 test to this on remote config loader. Let's say this PR it is added, right? So once it is merged, then we kick off automation using this commit hash and PR, and it creates backport and sends a message like it is backport. If it fails, it also says like a backport fail message, right? So like this, we have automated cherry picking as well. It helps a lot in maintenance effect. Yeah, yeah. So moving on to another automation we did part of Airflow 3 is documentation publishing. So documentation is key thing for everyone, right? On Airflow side, the behind the scenes, we are using the GitHub pages for publishing the Airflow site. So you see the Airflow site itself it maintains all the versions, right? You see Airflow has providers. Each provider has like it depends upon the provider. Some providers may have already 20 versions, or like some providers have main 4 or 5 versions. Yeah, Airflow has its own version. So all these box pages, right? It's a 20 plus GD which we had stored in Airflow side GitHub repository. So for release managers, if they want to release any document, any release version docs, right? So it's a lot of managers. They have to build the docs locally and check out these for 20 plus GB in your system. Checking out takes a lot of time, and raising API on top of that. It shows like many changes, and also it's hard to maintain, right? So, and another thing is contributions, right? So if anyone interested in front end like Airflow site, if anyone wants to contribute, the contributions are minimal because your site is 20 plus GB, and you need to check out and do this some development and raise API, right? And also let's say if anyone points out, hey, this page, this example is wrong, and someone notifies in our Slack channel, you need to patch that page, right? So the release manager, again, the same process, they have to check out the 10+ GB and to update that example or push it, right? It's all like hard to maintain, and it's a lot of effect for the release managers. What we did is we changed the shift to, we automated this process. You see here, right? On the left side are GitHub repos, Apache Airflow, GitHub repos, and right side live docs, right? So what we used is, we stored all these docs in the AWS S3. Thanks to Jarek and others. They helped a lot in this designing, and Ash also for helping out on this one. So what we did is we checked all these, we moved all our docs pages into Airflow or S3 bucket, Airflow S3 bucket, where we placed them, and we use GitHub Actions to automatically release managers can automatically publish all the docs to AWS S3. Then from there we are connecting via CloudFront to our Airflow site, which is in GitHub repository. You see the left hand side. So that now release managers, they can use GitHub Actions from the publish. They just need to provide the version of which version you want to publish. Then it does automatically. The action will build the docs and publish to Airflow S3 bucket, and also then it syncs back to the GitHub repository. So yeah. So, and another thing we are doing the behind the scenes, we need to keep a copy of snapshot of all the docs into the Apache Airflow on site post. So what we do is we sync back all the docs published to S3 into the Airflow site archive repo. Let's say, as I said, example, if someone by this concern like this example broken, this is not correct. So what you do is we raise the change back to the archive repo, then the archive repo syncs back to S3. So then the changes will replicate directly into the live site. So it's automated. So you see this now. So that's how we optimize the current docs publishing process. So you don't need of checking out the 20+ GB of site. You just check out a small push. It's like less than 5-10 MB of an Airflow site. You can check out and work out seamlessly. And we are looking forward for people to contribute in the Airflow site UI. So yeah, we welcome you all. Yeah, just conclude. So I think I covered pretty much the part which I work mostly. So handing over to back Eric.
So some more things that I want to talk about. Still we have times. So we have done some significant refactors and changes over the last year to improve our CI/CD, and it started with like securing GitHub Actions. First of all, like we got rid of the pull request target, which was unsecure. We switched the build to UV, as I mentioned before. We implemented UV workspace support, which is like a kind of a big step towards actually making our project setup more standard and being able to split out more Airflow into smaller pieces. We switched to Preg as pre-commit runner. This was the last thing that we've implemented, and we've heard a lot of good things about this move. Yesterday, I spent some time discussing the results of it, which was very good. We added some dependency version checks, which allows us to track what holds us back from upgrading new dependencies. We have some future features which I'll not go into many details, but just UV log support we have to add because we are not using it for now. We are considering splitting providers and maybe more parts of Airflow into separate repos. We are planning to switch to Apache Trusted Releases platform, which will allow us to deploy Airflow to API automatically from GitHub Actions. This is something that and to publish it to the Apache Software Foundation repositories. This is something that the Apache Software Foundation works on, and we want to add end-to-end tests for UI. We just started the discussion, so this is the last thing that we started to discuss about adding to our CI. So as a summary, we need the CI. We have the people who are working on that, and they are important. And we also invite you to help if you would like to help with our CI. It's pretty complex, but also it's contributable, and people can contribute and fix issues there. Thank you.